Welcome back to the channel. My name is Patrick and you're watching The Everyday Machinist. Please consider subscribing and commenting, liking and sharing this video. It really helps and motivates me to keep putting out content for everybody and really help educate people on the day-to-day things that I come across here in my small CNC job shop. So in this video, we're actually we're doing a little bit of work on one machine to get another machine set up. Now, we're going to be using the Haas SL30 ultimately, and originally when I had showed you guys in a previous video, it's for this aerospace part. Now the backstory. The lathe, as I discussed, you're going to have tool wear on titanium. Not necessarily is titanium going to break the insert, but it's going to just keep rubbing it down, wearing it down. So you're going to have a tolerance issue. Some of the ID boring, now nothing on the OD, we're good here on the OD, it's the ID boring, completely different tool. Originally, we let the ID boring go. It wasn't terrible, but we didn't change the inserts out as frequently. Our original thought was, as it goes in, and when you saw the previous video, as I started building the fixturing for these parts, the idea was, well, we'll just come down with an end mill and helical spiral bore the ID to just finish it off. But then that lends an issue where, okay, now we're decreasing tool life because now we're using that tool to then perform a bore here, and we're just kind of losing that tool. We could be using it somewhere else. So what we're going to do is we're going to do some cleanup on these parts. This part is actually good. The ones that need to be cleaned up are sitting over there. Conventionally, you have a hard jaw on your hydraulic chuck on your CNC lathe. Okay. This is a pretty basic one. Now they have ones where it has steps on it, kind of like a standard manual lathe chuck, removable jaws. And it has multi-steps and everything else. I had modified this a while back to kind of still give me a radius here and then an ID bore radius on the backside. It has serrations here to lock itself into the traveling part of the hydraulic chuck, two holes there to mount it. And then we have a slot here for our sliding nut. So our sliding nut sits inside of there to allow us to adjust the hard jaw and set it to where we need to set it. Our soft jaw here, this is one, we're going to make two more, and I'm going to bring everybody in on the video, just kind of watching it quickly mill some stuff down. Nothing too exciting, but it'll kind of add to the content of us building up to our build series and everything else. So we're going to start out with this. Now, this was 1.5 by 2 inch raw stock. I'm not going crazy on the outside here. We do have a bottom surface here, a top surface. Our two counter bores for the head of the socket head cap screw, and as well as the bore for the thread part there. Roughed the business end of this jaw to give us the clearance for the other three jaws. So that's that two surfaces here. When all said and done, as this is bolted in, it's actually going to sit just like that. So in the model, it's modeled that way to have this same profile, 2D profile, looking at it this way. Okay. So we're going to have a major bore here, a minor bore here, and a taper. It is in there. Now I could have gone ahead and machined, possibly roughed it out on that. But if I were to install these, it is still going to be somewhat precise, but I really don't want to take the chance to actually have it do that on the lathe. To do that contoured feature is not a big deal. So we're going to go ahead and just leave it to the lathe to do that. And then you know it's perfectly centered. Now again, we could rough it and walk it in over there. I want to leave it and let it lie, see how that works out. The other thing is the serrated feature on the back of this jaw. And again, that kind of locks it in. Now, getting into my repeatability, reliability, and consistency mantra that I like to preach, this wouldn't necessarily, real quick, I'm actually not going to be putting any serrations in here. If need be, we can. And I also figured we don't have to have the serrations run the entire length of this part here, of this jaw. We could actually do a section of serration, maybe a ½ inch section of serration here, and then mill down the areas we're not using so that they don't interfere with the serrations that are actually on the chuck itself. So that's what we're going to do. I'm not going to do that right away. I'm going to see how this goes. I'm actually mostly relying on the sliding nut. The sliding nut, being this surface here is a pretty good machined surface, it stays in there pretty well. So we got a pretty good fit, and it goes all the way to the bottom, no issue there. So it does fit pretty well. So we can set this to where we need to set it, and then lock it in, indicate the backside since that's machined surface, just to make sure the jaws are generally in the right area. And then we'll perform our profiling to receive this part. Very quick operation, actually not too bad to do that if you're talking seconds. So a little lengthy. We don't have that many to do, but it's something we feel to gain tool life out of doing this. This is 6AL4V titanium. We're going through tooling doing this, and it's really not that necessary. We decided to make a judgment call and just decide to do this. Reliability, I would imagine it would be there. Consistency, repeatability of installing them, taking them in and out, probably not. You would then be fighting, hopefully not fighting any cant to it due to this. A one-time use, I would hope, to fix the problem, so it's going to stay on that machine till the job is done. We're not looking to have a universal set of soft jaws for this right now. Even though we have a very generic hard jaw, what I've actually done is taking we had, I don't know, not an old ER32 collet, just one we don't normally use an ER32 tool holder, so it's a Cat 40 tool holder. What I wound up doing is I wound up just cutting it all down, cutting the taper off of it, and cutting down the actual or cutting down the actual, this part of it. So I lopped off that, this isn't it obviously, I lopped off the taper and machined down the remaining bit of the actual all this stuff right here. And with the ER32 body itself, it's actually pretty long. So we have a nice flat cylindrical surface to then clamp it inside of the hard jaws. And I have so many ER32 collets themselves, so it gives me a wide range of sizes. If I'm running small parts, I can then use the appropriate collet to then hold those small parts without really going too crazy. So it's kind of having these hard jaws in there is kind of universally set, where we kind of, set it and forget it and don't really have to mess with this too much. So it is pretty nice when it comes to that. So we can change out sizes, given it from, I think the biggest size we have is an inch, and I think it is an inch. I have to look. But an inch collet down to, I think it's 3 millimeter. So a wide range there. We have every single one, metric and standard. So that really comes in handy. That's really nice. So one of my reasons why I'm not really too keen, unless it's, again, for this specific purpose of doing this difficult profile to hold this part, then we're going to make soft jaws. But other than that, we're going to use some type of universal fixturing for that. And it is obviously consistent, repeatable, and the reliability is there with that. But again, production-wise, I guess it would be limited for a automated use, but you still could, it's a 3-inch bore headstock there, so you could, and then it has a bar feeder, so you can just keep putting rods in there and have them supported at one end. So it's not it's really nice to have that kind of thing. So, but back to this now, what we're going to do for repeatability and consistency on this jaw with this bore is actually, it's going to go the full depth. But where it sits, what we're actually going to wind up doing is having a stop inside of the headstock. So that's going to allow us to then push this against there. This way we have a consistent Z on it. So there's a little trick I have going on with that to be able to do that, allow it to just stop every single time. So, and that's only really for tooling, because we don't want to be protruding too far out. We have room to go in a little bit as well. But what we're going to wind up doing is, if we're too far out, then the tool is going to rapid and then engage before it's at the point where it thinks it's supposed to engage, start making a cut. Quick way to really destroy your tooling. So we're going to run with this. I'm going to bring you in. I have already done one. We're going to do 2 more here. I'll bring you guys in. You guys can look and watch. It's pretty basic stuff, making these. It's nothing exciting. But cool to watch, cool to see how we're doing it. We're doing it in a set of soft jaws, aluminum soft jaws I have in there, and then setting it up to get our appropriate X. Our concern is now the X0, which is in line. Now, On my, everything I model, again, going back to modeling vices, modeling tooling, modeling hardware, anything you possibly can, put it in there. Get the whole picture. Because again, even though it's only a 3-axis machine, you could still run into a concern where there's a bolt or something really stupid. I've done it. it's aggravating. It's like, well, why didn't I do that? And sometimes you're just busy, you're not thinking, or you think that it's going to clear and you don't bother checking it. Double check it, triple check it. It really is a huge, especially when you break a tool, it's a time saver. So, but on this particular vise, and what I do with all my vices is my G54, 55, whatever, my work coordinate offset is the back left corner for every single vise. So I have 4 vices in this machine, so it's going to be G54, 55, 56, and 57, okay? And then I have soft jaws in here, which the soft jaws are, again, raw. They have their ovaled hole in them, you know, for the fastener to hold it to the jaw body. And then we run a program to then, as it's in that machine, so where there's consistency, repeatability, and reliability, we then cut a 100 thou by 100 thou step into that jaw. Very universal. It doesn't, it provides just as much work holding if you were doing a larger part. It's plenty of bite. Now, you could run into the issue if there's a radius on the raw stock, if you're just throwing typical general raw stock in there with a pretty good radius, then you don't have as much clamping force on that. So that's something to consider. You should be prepping the raw stock to an extent, machining the bottom side of it as it's sitting in the jaw. So we run the program, we cut our profile into the soft jaw, and then we put our raw stock into that. So the reliability, consistency, and repeatability are there when it comes to just the setup of getting the raw stock in there to start actually making chips. So it's something to consider. Again, model everything, put everything you possibly can in there. Model tool stick out, the tool holder. Just like I preach every single time, it's reliability, repeatability, and consistency that are going to make and break your operation for whatever you're doing. I don't care if you're baking a freaking pie. You know, it's something you have to follow a recipe, right? So that's something that you should be considering is make your own recipe. So as lame as it freaking sounds, it's just something that I really try to push for everybody here and really try to nail it down, because it's just something we have time. Time is our enemy, so we can't be doing things, spending a couple minutes kind of making a procedure or getting used to a procedure is a lot quicker in time in prepping for that than it is breaking a tool, throwing a part away, you name it, crashing the machine. Everybody's done it. If you're out there, you've been in the industry for years or even a year or less, and you haven't crashed a machine, or you're telling me you never crashed a machine, you're a freaking liar. In some form or fashion, you've crashed a machine. So generally speaking, it does happen, and it's very preventable, but you know, there's precautions taken that you just have to do. This too, I think there's a guy on, I think he's mostly on Instagram, Old Boys, so Pat Old Boys on Instagram. He actually makes these. I copied it. Sorry, buddy. But I copied it because I wanted to see how it works. And I don't actually use this quite often, but here's my Renisar probe for this machine. But this is one of those preventable things where if you tell the probe to do something wrong, well, at first you want it to come down and touch this surface, okay? But you did the offset incorrectly, so it wants to go, instead of Z minus or Z positive, it thinks it's the reverse, and this thing comes all the way down. Well, this stops the machine once it sees pressure on the probe tip. Well, this could prevent that from happening, like coming down and stopping the machine from destroying this many thousands of dollars part probe. So one of the things, there are physical and or physical means, and things you write down, literature that you write down to prevent these things from happening. Steps, procedures, recipe. whatever the hell you want to call it. It's just something to always just have that, you know, mindless kind of thing. Everything should be back there, just a fundamental of an operation. So some things to consider. Throwing a lot at you guys right now, but it's okay. You're gonna get it. And the beauty of the internet, you can pause this video or go back and watch it as many times as you want. Sorry for talking fast or jumping around a little bit, but I want to get the point home of what I preach, and you know, it's kind of something I'm passionate about. So, all right, so we're going to jump into it. We're going to jump into just doing, finishing off these last jaws, these 2 more, and then we'll get it over to the lathe, and we'll start setting these up in the chuck, and then start running the profile and walking the profile in to get a really good fit for these parts. We don't have that many to do. It's just, again, one of those things which is understandable. It is a little frustrating with the tool wear, you know, extensive tool wear we get on titanium on this grade. So it is not a terrible loss to have to go back and do this stuff. It's just more, makes more sense because we're going to just destroy our end mills. Our tool time, our tool wear and tool time, if you don't know, it's going in the toilet. If you don't know, we're not going to run the part till breakage, the tool till breakage. A very silly thing to do. There's so much kinetic energy on that carbide and on the titanium. That thing is going to bounce around in there like you wouldn't believe. So that broken carbide is going to fly off and hit another done part, and now we just destroyed, definitely, obviously the end mill, possibly 2 parts, because when it breaks, it's sending it all into that one part that it was cutting and blasting it back out to another part. So we don't want those little tiny nicks and stuff in our parts. So we then have a set schedule on changing the tooling before it's ever going to break, based on empirical data, running it, a metric that we create to then change these tooling out before we encounter a problem. So that's something that you're going to have to do on the fly on these harder metals, and something that, if you're doing a large amount of volume or the parts are difficult, it's something to consider is tool wear and breakage on some of these things, and what the after effects could be. It's not just going to, most likely, commonly it's not just a broken end mill. Hopefully it's just a broken end mill. But when you throw away $40 worth of material, it gets a little upsetting, and the time it took to get to that point. So keep that in mind. All right, so we're going to jump right in, and we're going to get to doing some machining on these soft jaws. All right, so we got all 3 of these jaws done. Came out great, exactly what we need. So I'm gonna go ahead and start getting them set up onto the lathe and getting that done. I gotta do a couple things, some internal housings I have to do first. So we're actually gonna probably incorporate a little bit of this video footage in a different video. But right now we got them done. We're gonna get it set up, and we're gonna start doing what we need to do to get these remaining parts down to the size we need. I really appreciate everybody watching the videos, commenting. Everything looks great. Really motivates me again to keep putting out content for everybody. Again, you can find me on Instagram, Everyday Machinist. Get over there, follow me on there. Some things I post, some things I don't, some other cool stuff. We're getting into a little bit more automotive stuff as well for some outside vendors that we have coming in that want to partner with us. So that's really cool. Please look forward to that. We're going to do a couple of collaboration videos as well with a company called Reversion Raceworks. They're not too far from me. Great people there. They're making some pretty cool stuff for the automotive industry. We're really excited to be on board with them. So look forward for more videos of that specific content of us making some of these parts. I think that's going to be it for now. So check back for more videos, some more work holding and tips and tricks and stuff that I'm doing here. Again, probably next week we're going to see the rollout of our build series videos, specific build series videos on how we CAD, CAM, and model and write tool paths for these parts. I'm really excited about that. I hope you guys are as well. It's going to be really cool stuff, real in-depth look at what I'm doing here and my spin on it, I guess, if you will, how I approach from start to finish to these things, and you'll see a lot of in-depth stuff. So really pumped about that. Again, Everyday Machinist, comment, like, subscribe, share this video, please. I really appreciate it. It means so much to me. Thanks, guys, and we'll see you on the next video.